Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com.
Hello and welcome to this week's episode of Better Buildings for Humans. I'm your host, Joe Menchefski. This is the show where we talk about the impact that the built environment has on our health, our wellness, our productivity, our general joy of being alive. And of course, we always talk about sustainable design as well. We have a very special show today. Dr. Douglas Milburn, the founder and chairman of the board of Advanced Glazings and the sponsor of this show, and also the inventor of Solera and SoleraWall, is with us today. He's a serial entrepreneur, a passionate advocate for market-driven innovation, and especially in sustainable design. And he's a really interesting, cool guy as well. So this is going to be a fun episode. Doug, welcome to the show.
Thank you. I hate when you call me interesting and cool because I'm not sure I'll live up to that, but we'll try it though.
Well, he's not as much fun to be around as I am, but he's still pretty cool. So that's all right. So Doug, let's start by letting our guests learn a little bit about you. Tell us about your education, your career as an entrepreneur, and make sure that somewhere in there you wind in the story of how Solera came to be and how Advanced Glazings came to be.
Sure. Well, yeah, it's a whole lot. Let me see if I can make it simple as I can. So, yeah, I'm a proudly geek by nature, and I also like technical stuff, and then well, I guess that's the best way to say it. Mechanical, software, building machinery. I kind of liked it all. I went off to university. I took a physics degree, and I liked that so much. I took another physics degree. I did a master's in it was chemical physics and pretty cool research. I got to the end of that, and I was kind of thinking, I almost did a PhD in that subject, and along the way, I was just kind of thinking where the world's going and what I like doing, and I loved the research I did. I got great respect for that whole field, but I just kind of felt like I was leaving 99.999% of humanity behind when I went into such a specialized area. And anyway, I was at a place called University of Waterloo in Canada, and there was a guy there in the mechanical engineering department who was a pioneer in solar energy, solar thermal to be specific, and so like solar hot water, but also worked in high performance windows and the like. And I had the audacity as a physicist to walk over to the mechanical engineering department and ask this guy if he could do a PhD with him, which he kindly said yes. And yeah, so I did that PhD, and I had a bundle of fun and loved the university world, loved research, loved that time I was there. It was just so open and so much exploration. Anyway, I got introduced to something. He was the inventor of something called honeycomb transparent insulation. And it's exactly what it sounds like. It's a honeycomb material that is, we'd call it translucent, I guess. Colloquially, it'd be referred to as translucent. But, solar thermal didn't worry about whether it preserves an image or not. And it was an insulation material. So what it was for solar hot water collectors, you get a flat plate solar hot water collector, and it's got a black copper plate with tubes to catch the heat from the sun, and it's got one or more pieces of glass over it to allow the sun in and to not let the heat out. But sheets of glass don't work that well, and as we know, like windows aren't the best insulators in the world. So what would happen in the wintertime in cold climates, you'd lose most of your heat out through the glass. So anyway, he developed the idea using a honeycomb to do that. And it's the technology is really simple. You make those air spaces that are about just under a half an inch thick. It stops all the air movement, and it starts to create an insulation material. So anyway, I finished my PhD, which was in optical measurements. And I looked at that transparent insulation material. I said, this has an immense amount of potential. And I said, I'm going to start a company. I'm going to take this technology from the lab, and I'm going to create a company that basically commercializes it. And our first target market was commercial greenhouses, and which is a world you know a lot about. Joe, you worked in greenhouses 100 years ago?
Mm-hmm.
Well,
Yeah, about 100 years ago. Yeah.
yeah. So anyway, commercial greenhouses, these huge spaces, often, like 10 acres, 20, 50 acres or more underneath glass or plastic. and the insulation value is rotten. So the biggest check they write out is the heating bill. And anyway, this technology could reduce that heating bill by 80%. We showed. We finally developed enough material to do tests, a way to make the stuff, and we did those tests. But anyway, along the way, when we were doing that, the building industry kept on knocking on our door, and they had issues. And even go back, this is like mid 90s when I was starting that. And the whole issue of glass not insulating well. And there was a series of plastic products like this guy named Robert Keller Sr., who's actually a brilliant guy, and Kelwall is the product. And he started that company years ago. Very brilliant guy. But one of the technical issues he had, again, was to try to allow his material to let in maximum amount of light and still insulate. And what they do is they use like furnace filter type material. They stuff fiberglass in those cavities, what they did. And they start to lose light transmittance. So anyway, we talked to him. He spent a lot of time when visited them. Yeah, he knew my PhD supervisor quite well. He was a real innovator, really special human being, powerful mind. And then we had other companies in the skylighting side of things and doing skylighting and non-vision glass. And they had a problem. They had a problem of trying to let light into buildings and had to still insulate at the same time. So yeah, that was the roots of Advanced Glazings Limited. We got pulled over. We did a little pivot from the greenhouse industry, which I still regret. There's such an opportunity there. Mid 90s, people cared about heating bill for money reasons only. Today, it's carbon footprint, and it's a more pressing issue. And we have magic for that, but we've got our hands full doing buildings and help people create better buildings.
We're still young, Doug. We can always take a look at the greenhouse industry again at some point.
Absolutely.
Yeah.
Yeah.
Let's keep that on the list. All right. Let's talk about Solera and SoleraWall, the two products that came out of your PhD research that you commercialized. I want to understand how they function, and I think everybody should understand how they function and the benefits they bring to architects and owners. But first, before we do that dive, I want to talk more broadly about facades because it makes more sense when you truly understand that facades are meant to protect us from the extremes in the natural world, but they also are meant to connect us to that outside world. And that sounds like a simple idea, but it's not. It's extremely important. Can you explain to us how facades are supposed to both protect and connect?
Yeah, absolutely. Look, that's the heart of the matter, right? And human beings, one time I'm sure the only shelter we had was caves and the like, or whatever opaque materials what we had to get in out from the weather. We got to get out of the weather, right? And so you do that, and you go into a cave, and it's all good, and you're probably pretty happy if you have no other options. But today's equivalent of a cave is a big box store. And you go into these buildings that are built with no windows. There's practicality to it, right? And when you go into a building, big box store, they can become very energy efficient. Just put in huge amount of insulation in the walls. HVAC system controls the amount of fresh air coming in, controls the climate in there. And you can get artificial lights. You can get pretty energy efficient buildings. And you'll get down to a floor, because you need to heat, cool, make up air. And you need to put that lighting in and get that heat out from the lights. But it's not nice, right? Better Buildings for Humans is this podcast. And human beings, we only go into, customers only go into big box stores for short periods of time. And sometimes we pity the people who have to work in those under artificial lights and just not see the outside. So that's the disconnection, right? We go in to get out of the elements. If you do too good a job of getting out of the elements, you're really miserable because we need that connection to natural light and the seasons and cycles. As you've covered in the podcast, you disconnect from that. It is not good for you as a human being to get too disconnected from the environment outside. So, and then, the Romans thousands of years ago invented glass. And who knows how, maybe somebody had a really intense campfire on the right kind of sand or whatever else and said, hey, look at this stuff. This is cool. So they started, the building, stone buildings at the time, and you leave a hole in the stone building and then put a piece of glass in. You go, wow, we got the window. That's great. Why do they do that? Because they want to connect to the outdoors. And magic. And I'm sure, the early buildings with glass in it's just absolute magic when we take it for granted today. But and then glass is this truly amazing material because it can be totally clear and you can see an image through it. So you connect visually, you connect psychologically, connect awareness wise to the outdoors. It also connects you with respect to natural light, connects the outdoors to you as well. People outside can see in when the lighting conditions are right, and we got connection. But whoops, we have a lot of connection, don't we? Yep. And thermal,
Sometimes.
not a good
Mhm.
insulator. You got a thermal connection. If it's a snowstorm or if it's a heat wave outside and that heat and cold is coming to the inside, and you go, well, we don't like that. We love some sunlight coming in. We love daylight coming in, but direct beam sunlight causes real problems, causes glare. And then, oh, yeah, privacy. So, somewhere along the way, they invented shades, and shades do two things. I mean, number one, the whole light aspect, and it gives you privacy and protects you from that direct beam sunlight. And it also gives you an extra layer of insulation. And on single pane glass, being able to draw shades over in climate extremes are incredibly important. But what happens when you crank those shades over? You just depowered, like you're back in a cave, right? So, what's one to do if one wants to build a really great building and would really like to, connect to the outside? Well, and then along comes a third option, which is what we do, and that third option is translucent. And let me say the word ideal, or words, ideal translucent. So, an ideal translucent would have great insulation value, and it would be able to maintain that thermal disconnection. We want that thermal disconnection, right? And be able to maintain that. But we want when our building's lively at night, we want the community, we want that building to be exciting and to look good because our buildings are part of our neighborhoods. And having an opaque monolithic lump there is not very friendly to our community. And so we want the buildings to glow at night when there's activity in the interior. But the other side of it, probably more important, if you want to build a great building that's good for the human beings inside, like that glow is good for the human beings, the community outside, the human beings on the inside, you want natural light to come in. And ideally, that natural light wouldn't cause pain such that you pull the blinds down and create yourself a cave again. Yeah, I often pointed out over the years architectural presentations and poking architects a little bit into thinking about their work a little bit more, thinking about these fundamentals of design, and saying, you guys spend all this time convincing your clients that they need to cut holes in their well insulated opaque envelope and put glass in it. And then all of a sudden they convince them to put in large amounts of glass. Next thing you know, they're putting in large amounts of blinds, paying $25 a square foot for blinds that are an operational pain in the butt and maintenance cost. And oh yeah, you can't see out of them. And the filtered vision and filtered light it's just not, it's a rationalization of a bad situation. So anyway, you take an ideal translucent, it would diffuse light over the maximum range of angles. Because that glare problem, it's directionality. It's problem, it's quantity of light too. So if you control the quantity of light and if you spread it out over the widest range of angles, you mitigate your glare issue. And you end up with spaces that like the one I'm sitting in here right now, which is fully lighted. I don't have lights on here in the office, just glows gently. I got Solera up on the transom of the above my windows. I have windows that don't have blinds on them, and it's east facing, so I get some morning sun, which I welcome. It doesn't cause a glare problem for me because the rest of the building is backlit. So my use of this building, and this building has insulated metal panels as well, so it's good insulation, no thermal bridging, R21, pretty good insulation. And and it's got R18 Solera on it, and the vision glass is, I don't know exactly what the glass we spec'd in here is, but it's probably R4 or something like that. So, and a moderate amount of vision. So you're not starved for vision. You have the best daylight you're going to have. I don't have blinds, and we got a really energy efficient facade. So we've really managed, in the design of this building, we've really managed that connection between indoors and outdoors in a way, and we've actually protected view by using translucent, which is a really cool thing.
Okay, I need you to explain that a little bit more. Let's do a slightly deeper dive on that. How does a translucent glazing protect view. And I know I have to explain this every single day, so I need to make sure that the people understand this. So walk us through how that works, Doug, please.
Yep. If I put, we call vision glass, regular old glass you see through image preserving glass in the facade of a building. The interior of a building has a lower illuminance level, lower light levels inside the building it does outside. Bright sunny day, 10,000 foot candles outside. And I may be at 50-foot candles is a reasonable lighting design level. And when I put that window in there, I can use a heavily tinted glass if I want. But if I don't use a tinted glass, when I'm looking out that window, I see, if I'm in a 5 or 50-foot candle environment, I might see it's times light transmittance. I might see 7,000 foot candles when I'm in 50. It's a huge ratio. It's like 100 times more bright. It causes pain to my eyes. And then if direct beam sunlight comes in through that window, I get a bright patch of glare and concentrated heat, concentrated ultraviolet. It's a loose cannon roll around on deck. As the sun moves, it moves through. It hits my computer screen, hits my desk. If it's a workspace, if I'm in a restaurant, I'm sitting in direct beam sunlight. And so, and that's something that translucent can't do anything about directly, complete discomfort. However, here's what translucent does. If I take that environment and I put translucent instead of opaque around my glass, or instead of too much vision glass, I put translucent around there. I get that sunlight that falls on that, or daylight that falls on that, gets diffused, gets spread out through the room, goes up on the ceiling, brightens the ceiling, makes the space more energetic, more active, and it lights up the entire interior surface of the room. And when they do that, my overall lighting levels are higher, and especially in the wall directly adjacent to windows. So the contrast ratio is dropped. Glare is just contrast. Our eyes can handle very low light levels, and on a full moon night, people say, wow, is it ever bright out? Because you can see and you can function in very low light levels, half a foot candle. And then likewise, you can do 10,000 foot candles on a sunny day and operate in it. You just don't want to be in a half a foot candle environment and have 10,000 foot candles. Somebody take a bright spotlight and shine in your eyes. That's glare. So vision glass will have high light and illuminance levels associated with it. There's just no way around it. It's the physics of it. Right? Exception if you darken it down through tinting it. But if you, what you got to do,
then you have no light. If you darken it down by tinting it too much, then there's no light available to illuminate the interior if you just simply block too much of it out.
Yeah, and I think even worse if you consider the humans inside, right? Because when you go in, and anybody who's been in darkly tinted buildings know you can be in there all day, air conditioned environment, or and it's dark outside, and then you walk outside, you go, wow, it's like a warm, nice, sunny day out there. Wow, like you turned into permanent November, and it can be depressing for the human beings to be in there. It's like, I don't know, it's like the climate I'm in northeastern North America in the wintertime. We got relatively short sun hours, and it can be dark and cloudy. And people get caught up a little with seasonally affected disorder and the like, or you just feel kind of gloomy. Anyway, like tinted glass is not a solution for glare. It just removes daylight out of the equation, and it turns everything into like late November.
Right. Yeah, right on. Look, you just described an interior with well-diffused light. I want to dive a little deeper on that. It leads very nicely into this question. Tell us about the concept of conspicuous green and how it relates to ideal translucence and Solera specifically.
Yeah, sure. So, the green movement, I turned 60 last year. I'm not sure how that happened, Joe, but
Baffled myself.
Yeah, somehow crept up on me. So I've had lots of perspective, and so I was in the world of solar energy before. It was definitely not that cool being in solar energy or being green in early 1990. In those days, and I've watched the industry. I've watched the world evolve in its view of what green is, and there's two visions of green: the issue of climate crisis and response to it. Part of it, people talk about Jimmy Carter in the old energy crisis days, and who kind of seen, I don't know if he really did or not, but the media made him out to have a prescription that said, turn the thermostat down, put on a sweater, and shut off the lights to save energy. A deprivation green, if I could call it that. And you look at it, green prescriptions and innovations, the new energy code for buildings, and they ask for, to be green. They want a facade that by prescription in ASHRAE 90.1, they would like us to put 30% window wall area in as our norm. So when I look at 30% window wall area buildings and put vision glass in it, you're going to get bad daylighting, right? And the blinds are going to be closed. And the look of the architecture, I mean, you can build buildings, if you want to go like neoclassical, you can build buildings that, they look okay. But Soviet style brutalist concrete architecture falls under the 30% window wall ratio too. And you're just going to build buildings that they're a step backwards for human beings. And that's depressing. So that's one prescription of green. But I look at it the other way and I go, so we make our glass, or Solera, approximates an ideal translucence. We have versions that are up to R25 insulation values. So they're up there with the best insulating. You're way into diminishing returns and increasing insulation past that. And so you build a Solera building, it's the opposite of depressing or deprived. This is a true better building for humans. When you build a facade that integrates both vision glass, and you got to limit your amount of vision glass. You're not going to hit performance levels you need to meet building code if it's all vision glass. But if you do all vision glass, you're getting blinds and you're not getting your view anyway, unless they're lightly occupied spaces. So with translucent, you can get it all. You can do an all glass facade if you want. I mean, you can mix in some opaque, some good insulating opaque elements too. But you can build buildings that are exciting to look at, like really exciting. Like you look at, look at the new dealerships in Volvo Canada, which build these. I was just at the grand opening of one of those. Stunning building. Everybody involved with it is over the moon at how beautiful it is. Scandinavian architecture, integrating ideal translucent and vision, meeting wonderful energy goals. Some of them are LEED certified and just way jumping over all those bars for that. But when you walk in there, you're awash in soft, gentle light. Plus you have, copious amounts of view. You have all the view you want. You don't need to look out and around in every direction. In fact, sometimes you don't want to. And so you walk in there and they're retail. They want automotive retail. They want to build sustainable cars. They want to be in the lead of that. And they want to build sustainable dealerships. And they want to build buildings that sell cars. 30% window wall ratio car dealerships are not going to sell cars compared to the guy next door who's got more glass in it because the building's more exciting. The cars look better under natural light and everything else. But they are such a step ahead of the status quo in that. And you walk in there, the green is conspicuous. Let me jump to one more example, Joe. We have an arena project in a community called Port Hawkesbury. Again, I'm going to jump. It happens to be in Canada, but this arena, we built this a long time ago. The arena is naturally lighted. It's got a strip of Solera up around the top, sort of mansard style roof. It's got a strip of Solera up around the top. And the lighting in there, they wanted to make this, they wanted to build the greenest world. It's 2006, I think they built it. They're ahead of the curve. They want to build the greenest arena and civic center in the world. And they won an award from Business Week, world's top 10 sports facilities, which was quite an honor for this little town. And to be up against some of these mega things like an Olympic Stadium in Greece and things like that, and the like. And it was really a wow honor for them. But the people that wrote it up had 3 paragraphs on it. 2 of them were about the natural light, because you walk in there. What did the natural light do? Number one, the natural light was natural light. Like the lights are not on in the daytime, so saving energy. Number 2, the daylight in there, they used a spectrally selective glass. The daylight in there is dramatically cooler than artificial light. So they designed for about 50-foot candles, which is about the design that you do in artificial light. 0 energy going in to put that light in there. And about half the energy that LED lighting, it would have been probably metal halide in 2006, but be about half the energy that LED light would have that they'd have to remove in the air conditioning, which also allows their ice quality to be better. They had an international curling tournament in that arena, and people raved about how good the ice was. So just really cool, win-win. But you walk, and then they had another innovation in that made them green. They had a company that was, I believe, it's called Ice Cube Systems, and what they did, the heat pumping. So they'd heat pump the heat that comes out of the ice surface would either get pumped back into the civic center, the attached civic center to heat it in heating season, or it would get dumped under the parking lot in the wintertime and geothermal heat sink. And that actually saved more kilowatt hours of energy than our daylighting. But our daylighting, we got 2 full paragraphs, they got 1 sentence. Why? Their stuff, and important, but it's locked away in the server room. And it doesn't make the building better for humans. Okay? Natural light and that thermal comfort that comes from a well-insulated envelope and that glowing at night for the community just create buildings that are really better for the people around the building and the people inside the building. So that's what we call conspicuous green. Green should not be, in my mind, green should, number one, be first choice for people building a building because it's just a better building. And it should not be forced on people, and it should not be a burden for people, in my opinion. And I know there's another camp out there that says we want to legislate this dark Soviet style world in green. I don't think it has to be that way. And I think it's just the wrong choice. And I think the world risks a serious backlash that if green is a burden that people have to carry and not a benefit that just takes us to a next level, beautiful new world.
Yeah, absolutely. I couldn't agree more. I want to jump a little bit on the Port Hawkesbury Arena thing. It sounds like it was a relatively small amount of glass that is illuminating a huge space. So that, that I know the answer to this. I just want to hear you say it. Is there a killer app for an ideal translucent? And if so, what kind of buildings are ideal in terms of their actual geometry, but also in terms of like certain types of occupants that would benefit the most from a well daylighted space?
Well, you know what I want to say is a range. Like there's sweet spots. Let me talk about the sweet spot. The large space, the arena. We do a lot of arenas and big public spaces and things like that. And when you put like Port Hawkesbury Arena, people who walk into the arena, they say it just feels great. Like that's it. Like people who know nothing, translucent daylight, that's up. That's well, it's mansard roof slope, but it's it's a clear story position. It's way up there, and I don't think a lot of people look at that. But what they do is they say, when I go in that arena, it's just amazing. But all that said, that arena, it's a small town arena. They didn't have a big budget. And that was 2006. Construction numbers are completely different in 2006 from what they are today. But that was, I believe, the budget for the arena was $150 per square foot of floor area. Like that's an inexpensive building. And a step above it's not your ultra totally budget arena, but it was not high end finishings or super high end finishings. It's nice, but you walk in there and it just gives this. People talk about open, clean are the words they use to describe it. And it's just comfortable to be in there. So large spaces and very easy to daylight because you got lots of facade on it when you can everything skylight and sloped horizontal, and there's lots of opportunity to put light into those spaces. And yeah, Port Hawkesbury Arena, killer apps. You know what? The answer is there are sweet spots. Very versatile. A lot of things can be done, but there are sweet spots. And one of them, as you mentioned, is large spaces. Port Hawkesbury Arena, it's a space that people go into and forget if they've ever heard of us. I talk to people. It's an hour and a half's drive from where I live. And I talk to people who go there, their kids will play hockey there or something. And they say, this is the most beautiful arena. It's unbelievable. And I'll ask them, I'll say, well, what do you like about it? I don't know. It just feels like open. It's like clean. And it's not about it being an expensive arena. It's not at all. It's the natural light in it that just gives that a really special feeling. Anyway, that's large spaces. Yeah, large spaces, there's a lot of facade around large space. You can go roof and horizontal, vertical surfaces, slope surfaces. It's pretty easy to get light in and create spaces that people just go, wow, that is a truly amazing space. But other spaces, I'm sitting in an office here, and the office it's a really great application for it. I'm in, I don't know what this office is, maybe 10 by 16 or something, the office that I'm in. And it's got great daylight, absolutely wonderful daylight. The lights aren't here at all. And when I'm sitting in this office, I don't have any glare issue of note. I use my computer in this office. It's a good office. It's just really nice. So that's a great application for it, is workspaces, to create workspaces for people. There's a cubicle area in this building that I'm in with about 50 people in it. And we had a visitor here who said early in his career, he said he worked for Bank of America, and he said in cubicle farm, and which have a low dropped ceiling over it and fluorescent lights at the time, and they can be quite non-human friendly spaces, say. And he walked in there, he says, wow, this is just amazing. It's open, it's clean, and that light, you get that natural light, and you get that feeling. And in a workspace, when you're in there your best 8 hours out of 5 days of your week, that connection thing, it's so real. It's having that light change from the morning, the spectrum changes, the intensity of the light changes, the weather changes, the light inside changes. It just connects you to the outdoors. People just talk about feeling so much better in the space. So that workspaces they're killer apps for daylighting through translucence. The other one, we think retail, and it's really in its infancy. When you look at retail, so much retail is like gone big boxy, plaza-y, and they're struggling for their life against, I think they're hitting an equilibrium on it, but struggling for their lives against online. And it is so, and as that happened, as they went over capacity in retail and their lunch got ate by the online guys, it became intensely competitive. Those who know how to create great retail environments will survive and will thrive. I look at the grocery store business in Canada. I live in Canada, and the grocery store business went from intensely competitive, very, very low margins, and grocery store business went from zero 25 years ago, 30 years ago. There was no glass in grocery stores, maybe a little bit in the doorway. That was about it. Now they have the two big competing chains, but more and more glass in there because it creates a better retail environment. Now, they aren't using, they started that a long time ago before there was a really great glass-based option. And so now they struggle up against energy codes. And at the start of it, they dealt with the glare issue. They've dealt with direct beam sunlight coming around, hitting the stock, overheating food, cash registers, scanners not working, employees being uncomfortable. And they've dealt with that. But the benefit of glass was bigger than those penalties. Now we can build things, and we look at car retail, and we look at those Volvo dealerships, and they're going, wow, these guys, in retail, the grand opening I was at in Halifax, Nova Scotia, and one of the first things I did, I went and talked to somebody who was actually the financial manager in there. And she said the 2 months they've been in there she's been in the retail industry for quite a few years. She said they're by far the best 2 months she's ever had in her time in the industry. So it's, again, green. They got people in retail chains, and they are, if you're the manager of sustainability in a retail chain, I think a lot of these people feel like they're paying the ass and they get ignored because their business priorities squeeze green, when we can. And I'm not down on them on the chains for not jumping to green right out of the way, but they are, retail is not a big margin business. There's not a lot of money to pay for it. But the wonderful thing that some people are getting in retail now, and we have a number of conversations going, is that green is not a cost, it's a benefit. It's a top line driver in retail. So retail is big. Oh, and may I, just so I don't run on forever, I'll finish off by saying education is understood for years and years that students learn dramatically better, measurably better under natural light. And yet it is challenging, because of the properties of glass, to put good natural light in classrooms and not just end up with blinds that are closed. And Joe, as you know, we in Advanced Glazings, we've hundreds of schools, and we've contributed to school designs that have absolutely great natural light in the classrooms. Plus, in schools, they don't stop at the classrooms. They have large space. They have cafeterias and libraries and gymnasiums, too, that benefit from it. And education's been wonderful. We've had the honor of helping people create incredibly great buildings that are healthful, better buildings for humans in the education space.
Many hundreds of schools closing in on the magic 1,000 number, actually, quite
Yep.
close to that. So,
Yeah,
yeah,
that's cool.
really exciting. Doug, I wanna go off script. I wanna go off script a little bit. I wanna talk about something that I run into on a regular basis, and, so, everybody knows that bringing natural light into a building, the terminology that's most commonly used in architecture is daylighting. And if you grab a book, just hop on Amazon and grab a book on daylighting. The majority of it is going to be some pretty complicated stuff, overhangs and light wells and things like that. And I talk to consultants on a regular basis, very well intentioned people who care very deeply, who will tell me that the only way to effectively bring natural light into a building is with external shading methodologies. What's your feeling on that statement?
Well, you know what? I suppose if you went back to 1700, you talked to people about the only way to get down to the general store was by horse. I think there's a lot of truth in that. But again, humanity moves forward, our technology, our ability to solve problems moves forward. You know, it, with just vision glass carries glare with it, it's inherent. So the idea in overhangs, of course, is if we put overhangs, deep wells and things like that in buildings, and we hide from the direct beam sunlight and we can get good daylight in. And it's absolutely true. It's just that it's incredibly problematic. The practicalities of buildings, of trying to maximize space, use the site that you're on correctly, deal with, compass direction of the different faces of the building. And so it becomes very difficult to do that. There's also a lot of self-delusion that goes along with shading devices. You see somebody wants to put shading devices up. They build a curtain wall building with a significant sort of south-facing area. And next thing you know, they got all these wings coming out of it, flying off it. And oh, they're shading devices. And those shading devices have some utility in terms of controlling solar gain on a seasonal basis, in that noontime sun. And if you're south facing, you can selectively shade out some noontime sun and still get natural light in it. But in terms of daylight, glare from direct beam sunlight is an instantaneous problem. If this is an active space and an occupied space, if it's not active and occupied, it's a totally different story. But if it's an occupied space and people in there get direct sunlight falling on them, on their work, on their computer monitors, or their restaurant table, or whatever else, you're going to go close a blind. And if you're in a workspace, you don't have a blind, you're going to put up, we see people put up cardboard or tin foil over cardboard and all kinds of things to protect themselves from direct beam sunlight. You have to protect yourself. And you know what I keep saying about all those lovely ideas about shading device? Oh yeah, it's great. And at noontime, it'll shade. And I go, yeah, but the darn sun keeps moving. Pesky thing about it, right? It keeps moving around the sky. And if you look at a south-facing facade, you're going to get grazing sunlight 6 hours before noon, and you're going to get grazing hours sunlight 6 hours afternoon, and then everywhere in between, it's coming up and swinging around. It's coming in underneath those shading devices. So, yeah, there are examples of great daylighted buildings, costly, site restrictive, totally dictate your architecture. Oh yeah, incredibly expensive. So, yeah, the ability to use an ideal translucent just makes it practical without putting expensive wings. And maybe slightly, maybe it's what you want to do architecturally, but a lot of times it's not necessarily what they want to do architecturally. So that people go by and say, oh, that's butt ugly. And anyway, you got the beauty's in the eye of the beholder. But some people might not like the look of translucence. So, well, good. Not everybody's going to love it. But translucent is just a lot more flexible. And the other interesting thing on it, Joe, you will end up with blinds in most shading device situations. The incremental cost of Solera in curtain wall is almost always less than the price of curtain wall vision glass plus blinds. So it actually saves on true first cost, which is another fascinating way to look at it. So, and every time we've talked to people about priced out shading devices, pick that thing, a curtain wall with shades everywhere, it can be very expensive because of all the structural concerns and all the engineering that has to go into it. So.
Yeah, and if you look at Michael Kent's work in regards to view quality, Michael, we're finding that view is also important, just like daylighting is important, just like fresh air is important. It impacts our mental health, it impacts our physical health, and everything that diminishes view quality, anything that obstructs or diminishes view quality, obstructs and diminishes the amount of benefits, physical and mental benefits that we get from the view. So when we start putting complex patterns and things that block the quality of our view and reduce it, we're simultaneously hurting the physical and mental health of the occupants of the building. So that alone is a reason to balance the view with vision glass and with the translucent rather than putting things in front of the vision glass. It's just not optimal. Okay, I'm going to have you back on again, Doug, because we're running a little bit long. But I want to ask you the $1,000,000 question. As you know, every single show I ask this question, and I ask the guest to answer it from whatever perspective they'd like. Doug, what makes a great building?
Yeah, I absolutely love the question. I love listening to your guests answer it too. My take on it is a great building's one that just feels good to be in, and one that people, the building I'm in, it feels good. Why does it feel good? The layout's interesting. You walk inside, it's not dull and boring, it's not oppressive. It's got view. I'm in a, it's industrial park. It's not like sitting in, I don't know, I'm in Seattle or Vancouver looking at the mountains or something. I'm not looking at it. But I can see out. I feel good because I can see out, and I have great daylight. And I also, in these buildings, the new buildings we're building inside the businesses I'm involved in, we have about 4 times the normal rate of fresh air coming in. The air is fresh. I got natural light. I got that flow, the flow of the day and the flow of the seasons. I can feel it. I can see, and it's interesting. Those are the elements as far as I'm concerned, Joe. And a great building when you walk into it, it's about how it feels. And it's not one element. It's all these things together. But view, daylight, and fresh air are strange. That's what you get when you're outside, isn't it? And exactly what you get when you're outside. So you get that with thermal comfort and getting out of the rain and the cold and heat. That's it.
Beautiful. I love that. Doug, before we go, is there anything you'd like to announce, anything you'd like to promote, anything you want to share?
Yeah, absolutely. This whole thing, I'm so incredibly proud to be part of this whole movement of, I love green, but I like better building green. That's my passion. And and anybody, I know I'm marketing when I say it, anybody who's really into building a better building and that natural light and view are part of it. Love to talk to you. We have all kinds of interesting and wonderful things and ways to solve problems. So those visionaries out there, if it's a visionary project, we love getting involved in those. But we also love getting involved in just, our bread and butter is things like schools and commercial buildings and things like that. And absolutely love getting involved in them. So.
Doug, a pleasure as always. Thank you for being here, and I will have you back soon because there's so many more things that I want to hear you talk about. So thank you. It's been a wonderful conversation.
Thank you, Joe.
Take care.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.